Okay. So you'll have all the code and stuff for your reference, or watching me type for your reference if you need it. Okay, so I've opened Jupyter Lab. While it's thinking about that, it always takes it a second. Let me go over to Moodle and show you what we're going to be dealing with today. So if you go to Friday, April 16th, there are several spreadsheets we're going to deal with. So county demographics, LA zip code, and so on. There's also this text document called sample code. So this is where I'm going to pull code from, just like I did on Monday. Let me see if Jupyter Lab. Okay, so again, for me, when Jupyter Lab opens, it's a gigantic mess. There's just stuff all over the place. And as always, remember, I'm an old man. if I'm supposed to be sharing my screen and I'm not, you have to yell out to me. Anyway, so when Jupyter Lab opens, there's just a bunch of stuff in here because I use it for my work. For you guys, there's not much here. So you just have to ignore all this when it's on my screen. I'm just going to open a new one. So you can open a new one also, or you can just continue with your one from last time. So now I have a completely fresh Jupyter Lab notebook here that I'm going to be putting sample code in. So I'm just going to give you guys a minute just to see if maybe your Jupyter Lab launch is slower than mine. So I'll just pause while you guys are getting that fired up, if you want to fire it up. Okay, so assuming people have this up, and again, if something goes wrong for you, you can yell out. If you need me to slow down or whatever, just yell out. Or again, I check the chat periodically, but when my screen is shared, it doesn't show up for me. Okay, so the first thing I want to do is download this Excel file, CSV file called County Demographics. So I'm going to download it. And first, I just want to open it and show you kind of what's in there. This is a CSV file that I got from the Harvard MIT Election Lab collaboration. So they collect data to analyze elections. So if you open it, there's like a lot of stuff in here. It's a gigantic spreadsheet. So every single county in the US is in the spreadsheet. So Alabama has, I don't know, 80 counties or something. So Alabama, then it moves on to Arizona and so on. So every county has what's called a FIPS code. We don't really care about that. And then this document has the vote total for Donald Trump in 2016 from this county. So in 2016, that's why there's a 16 there. In 2016, 18,000 people from this county voted for Trump and roughly 6,000 voted for Clinton. And then there were 865 third-party votes. And they have the same kind of information for 2012. This document does not have 2020. They haven't updated it yet. So anyway, this document came from the Election Labs collaboration. And what they're interested in this lab anyway, is thinking about correlations between demographic data and vote data. So they have a bunch of other stuff in here. If you scroll over, they have like the percentage of the county that's white, the percentage that's black, percentage that's Hispanic, and so on. So if you're interested in like, you could ask questions like, so the higher the percentage of Black people in a county, what does that do to like the Democratic or Republican vote totals? Is there a correlation there? You can ask questions like that. So my only point is this CSV file is huge. It's got a bunch of columns. I see I'm still scrolling to the right, finally stops here. And it's got a bunch of rows. There are something like 3,000 counties in the US. So this spreadsheet goes on for a while. This is the spreadsheet I want to feed into Pandas today and have it analyzed for us. So that's just what the spreadsheet is. Now, if you want to see full documentation of this, there's this link here, County Demographics, CSV, blah, blah. It takes you to this, this website that tells you what every column is named and what it means. So like, if you couldn't figure out, like Trump 16, what does that mean? It'll tell you. Presidential candidate vote totals in like 2016. There was a column called CVAP. What's that? CVAP? They tell you it's the citizen voting age population. So just the number of citizens who can vote in that county. And white percentage, we all know what that means, I think, and so on. But anyway, so this website documents the spreadsheet for you. So that's the spreadsheet we're going to be dealing with. Okay, any questions or concerns so far? I can't see your faces, so I have no idea if you're with me or not. Let me just check the chat real quick. All right. Okay, so now before we get the code up and running, the code that I wrote, and I'm always ashamed to show you my desktop because it's such a mess. I'm not ashamed enough to fix it, so I guess I'm not that ashamed. The code that I wrote always assumes that the files we are crunching are on the desktop. So what you need to do is, after you've downloaded this, take this and put it on the desktop. Now for me, it's already there, so I'm not going to actually drag it. But the code that I wrote assumes the file is on the desktop. If you want to put it somewhere else, because unlike me, you're bothered by this crowded desktop, you can give the code a different file path. But the code that I wrote that you're going to copy and paste assumes things are on the desktop. So you take this file that we downloaded, put it on your desktop. Now let's go to the code. So if you click on the sample code text document here, then just like on Monday, I just have some sample code to type in. Notice there's not a ton here, but there are just some things I want to show you can do. Okay. And actually, the most important line of code is missing. So anytime you're going to use JupyterLab to crunch data, we're going to use pandas. And notice this line from last time is missing from this document. So you should start like that. Import pandas as PD, just like we did last time. And depending on when you're firing this up, this might take it, 30 seconds or so. Pandas is a gigantic library, so it might take it a minute to think about. Okay, so now the question is, right now, on my desktop, I have this spreadsheet. It's in a CSV file. So right now, the program has no idea. JupyterLab has no idea what this is. This data is completely inaccessible to it. So how could I feed this spreadsheet into pandas as a data frame? It turns out there's a very easy command to do that. It's just called pd.readcsv. So let me copy and paste that line of code in here. Now you have to give a name to the data frame that you're creating here. So I call it data. You can call it whatever you want. You can call it my spreadsheet, whatever. The names are up to you. You call it X, it doesn't matter. Okay, so again, see this file path here on the desktop? I'm assuming it's on the desktop. So I don't know if you noticed, there was a little star icon right here for just a second, and then it said a 2 right here. So when it has a number, that means it's done thinking. So in literally half a second, it read in this data frame. And now if I ask here in cell 3, hey, data, what is that? And I run this. Again, you can click run. On my keyboard, I just hit shift enter because I don't like having to click run. It shows you that spreadsheet. So here is that spreadsheet, but it's not a spreadsheet on your machine anymore. It's a data frame inside JupyterLab. So JupyterLab and Pandas have eaten in this spreadsheet for you as a data frame. So now all the data frame commands we have will can apply here. So you scroll over, it's pretty big, right? There's lots of columns, so ... It's not going to show you all of them. But there you go. There's all the data. And then if you scroll down, ... right? It skips from line 29 to line 3084 and so on. So there are 3,113 counties in the US we've just learned. So let me again pause here and see if anybody's having any issues. I'm just getting this to read in. As always, you have to have the exact, this syntax here has to be exact. The name doesn't matter. You can name it whatever you want, but if you change the code, the syntax on what I have, it can really mess things up. Okay, so now let's just start analyzing this. And much of what we'll do are commands from Monday, but I want to show you some new commands that we'll do today. So the first thing I want to show you is, so suppose you've eaten in this data set here, this Excel spreadsheet, and you're like, wow, there's a lot of columns here, like dot, dot, dot. I wonder what's all in there. You know, so you want to just get an idea of what you're looking at here. Let me go to the next cell. Yeah, I have this next little command here, data.columns. You can always ask pandas like, hey, this data frame, what are the columns? And it'll just list them for you. So now you can see, oh, so there's a column for state, column for county, column for FIPS code, and so on. Column for white percentage. This must mean Republican governor votes in 2014, I guess, things like that. And again, some of these are not particularly well named. Like some of these less whites percentage, I guess. What does that mean? It probably means less than high school education, but you don't know. So for some of these columns, if you don't know what they mean, like CLF, unemployed percent, again, that's why I provided this documentation link here. So if you're like, what do these columns mean? So let's look at that, the CLF. What was it? CLF unemployed percent. Let's see what that is. Where is this? Okay. Unemployed population and labor force as a percentage of total population and civilian labor force. That's what that means. Okay. So there you go. Less HS percent. Population with an education of less than a regular high school diploma as a percentage. Okay, so again, if you're confused by what columns mean, that's why I have this documentation here. Is everybody okay with that? Okay, so as with last time, we have this dot describe thing. You can ask for that. You can have it describe any particular column you want. So total population is just the population of the county. So if you do that, now I should say, JupyterLab is kind of weird sometimes and how it decides to display data to you. So if you're not used to scientific notation, this is obnoxious. So what this is saying is 3.111 times 10 to the third. So what it's saying is you have to read this in the thousands. So 3111 thousand. 3,111 is what it's saying. It's counted that many populations for you. So this just means like basically shift this decimal point over 3. And like when there's a 5 here, you got to shift it over 5. So 1, 2, 3, 4, 5. So the average population size of a county is about 100,000. Standard deviation, we don't really care about. The smallest county in the country, see this 01 here, so you shift the decimal point over 1, that's 76 people. So there is a county, and I believe it's in Texas somewhere, that has 76 people in it. On the other hand, here's the biggest county here, Max. So there's an 07 here, so you got to move the decimal point over 7. So 1, 2, 3, 4, 5, 6, 7. So you're talking like, what is that, 10 million people or something? 10 million or 1 million, something like that. Anyway, so the smallest county is 76 people. The biggest county is in the millions. This is probably Los Angeles County or something. And the median county, move it over 4, 1, 2, 3, 4, is like roughly 26,000 people. So again, Python, just like pandas, it knows which column you're talking about, and then it tells you a bunch of descriptive statistics about it. It doesn't know exactly what you want, so it tells you a bunch of stuff. So again, that was a command we had last time where we had a data frame we built. Now you can start to see why this might be more useful. If you just want to analyze the spreadsheet on your own, it can take you a while, right? Just by staring at the spreadsheet to get this sort of information. Although I guess Excel can, of course, do some of this. But anyway, so anyway, there's a command from last time. Another thing to point out is that this spreadsheet, as we know, has a bunch of columns. You might not care about all of these columns. So for example, maybe you only care about demographic data. You don't care about the political data. So you're like, I don't care how many third-party presidential votes there were in 2012. I don't even like worry about that. So if you want to sort of pluck off certain columns while ignoring others, you can do that with a command called filter. Basically, we saw some data slicing last time where you can pluck off a single column. This lets you pluck off as many columns as you want. So I'm going to ask it to create a new data frame from data, but it's only going to keep these 4 columns. That's what this command does. So I want to keep state, I want to keep county, I want to keep total population. I'm also interested in, recall, this is citizens of voting age. Okay, so let me just run this and see. It's just like, oh, you want those 4 columns as a data frame? Well, here you go. State, county, total population. And this was the number of people who are of voting age and citizens. Okay, so notice we don't have that many commands left, right? So I want to stop here and ask any questions, any comments? Anybody having any issues with the commands? Okay, so the next thing I want to show you is, given a data frame, you can add information to it if you want to. And that's sort of a useful thing to do. So notice in this data frame, I have the total population of the county. I have the number of people who are civil or citizens and can vote, but I don't have a percentage. So, you know, the raw numbers here might be kind of misleading. A percentage was sort of cut through. Like, are there sort of more citizens here than here that can vote? I mean, yes, because this is a way bigger number. But is there a larger percentage? I don't know. So what you can do is you can say, well, I want extra information, and that extra information would come from the combination of these 2 columns. You can then create a new column in your data frame that has what you want, and you can do it like this. So watch this. Yeah, that's the command I want. So just the next command that I haven't copied and pasted yet. Okay, so I'm gonna tell pandas here, like, hey, I want inside data frame 2, I want a new column, and it's gonna be called this, percentage citizens voting age population. And again, you can call this whatever you want. You can call it X if you wanted to, but that's not particularly descriptive. And then you tell Python how you want this stored, like what do you want it to create here? And if you want a percentage of citizens voting age population, you just take the number in this column and divide by the total population. That's how you would create that percentage, as a fraction, I guess, not as a percentage, but whatever. Now, if I run this, see, it puts this extra column here, and it's taken this number and divided by this number to get this 0.739. This number divided by this number to get this 0.76, and so on. So I guess percentage is maybe slightly misleading because these are decimals. So you can, as a decimal, you can name it even more descriptively if you want to. So it's like percentage as a decimal. Anyway, so you can create new columns from old columns if you want to. You can divide, you can add, you can multiply, subtract, whatever. So again, this is pretty powerful here, that within the data frame, you can do this. Now, again, all of this is happening within Pandas, within JupyterLab. So this spreadsheet that's on my desktop, this spreadsheet is not changing. See, it's just the same. So what we're doing is we fed that spreadsheet into Pandas into JupyterLab, and we're slicing and dicing within JupyterLab. So this df2 only lives within JupyterLab. It doesn't exist in its own spreadsheet as a CSV file or something. Okay, so now suppose you wanted to know, like, these percentages, what's the biggest, what's the smallest? You know, what county has the highest percentage of citizens of voting age, and what has the lowest? You can just sort things like we've done before. We did this on Monday. So again, it's just the same command, but now we're doing it on a real data set, not a toy one that we made up. So again, sort values is what you do. You have to tell it what you want it to sort by. I'm sorting by the percentage. And since I didn't tell it to sort from biggest to smallest, it defaults smallest to biggest. So here you go. So Zapata, Texas has the lowest percentage of citizens of voting age population, less than half the county. So in Texas, you're going to see 3 of the top 5 like that, or by top, I mean the smallest percentages. They're all under 50%. So there are a couple of things that could be happening here. How is it possible, I guess? Let me ask you guys, how is it possible to have such a low percentage of your population be citizens of voting age? What's going on there? Any ideas? And if you just tuned out, let me restate the question. This right here, this is saying 43% of the people in this county, 43% are citizens of voting age, which therefore means 57% are not that. How is it possible? And it's not like there's only 70 people here, right? There's 14,000 people. How is it possible to have such a small percentage of your population be voting age?
Could it be lots of illegal immigrants potentially?
Yeah, so there's one idea, right? That there could just be lots of undocumented immigrants. Those people are counted by the census. And as far as I'm aware, that's where these sort of numbers are coming from, or from the American Community Survey, the sort of census light thing we do in between censuses. So, yeah, that's certainly one thing that could be happening. Lots of undocumented immigrants. Any other ideas? So, it's also possible that this is a super young county, I guess, right? It's just possible there's tons and tons of kids. That would get this percentage low. So who knows, actually, right? It's probably a combination of those two, but given so many Texas hits, I mean, either these counties in Texas are producing tons of children right now, or there are lots of undocumented immigrants. It's probably the latter, I guess, but it could be some of the former. Anyway, so there you go. So you can start to see, and if you want to see the top 10, you can put a 10 inside the head. Wow, Texas, 8 of the top 10. And we still haven't even broken 50% here, right? So again, in Texas, either lots of undocumented immigrants or lots of children. Oop, oh, here we go. Oh, we get some Kansas hits. All right. And finally, we break 50%. So now we've learned, by the way, we learned very quickly. This is the kind of question that we probably couldn't have answered quickly without this kind of tool. If I'd asked you ahead of time, hey, how many counties in this country have a percentage of the population less than 50% of citizens who are of voting age? Like, how would you answer that question? I don't know. That seems pretty hard. But now we can just look. Like, we can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 counties like that. So the computer just like told us. Anyway, if you want to now sort it the other way, I don't know if I have this officially in here or not. If you want to sort it the other way, you do what? Ascending. This is just a command from last time. Ascending equals false. And now it'll do from biggest to smallest. So Forest, Pennsylvania, that county, 95% of the county is citizens of voting age. So this county, in contrast to those Texas counties, they probably have like no undocumented immigrants and they have like no children also. So it's like an old, probably, I don't know, you'd have to look, right? But it's probably just a very old county with no undocumented immigrants. Anyway, so again, this is the kind of power you have with JupyterLab and with Pandas. It all just depends on what questions you want to ask, what you have it do here, right? So if you're interested in like percentage of voting age population, it just does that for you. It just tells you. That's pretty nice. So let me just show you a few other things. So let me create now another data frame, DF3. This is going to filter the original data frame. So remember, the original data frame is way back up here somewhere. So I know it's obnoxious to watch people scroll really quickly. I don't want to give you eye whiplash. So data is still all the original data. It's all this. What I was messing with a second ago, I'd called DF2. And I did that because I didn't want to change the original data frame. So when you eat in data, a lot of times, and when I say a lot of times, I guess I mean all the time, really, most of the time, you have your original data eaten in, then you create sub data frames later, like to mess with. So you don't overwrite your original data, you make copies and then slice and dice within those copies. Anyway, so now as I scroll down DF3, I'm going to filter by state, county, total population, and Hispanic percentage. So again, you can just pluck out whatever columns you want. And then now I can recover if I want to. Notice here, since I know the total number of people in the county and I have a percentage of Hispanic population, if I wanted to not have the percentage, but I wanted a raw count of the Hispanic population, I could do that with a command like this. I could create a new column called Hispanic population. So this, again, will be raw numbers. And how do you recover raw numbers from a percentage? Well, you take the percentage, divide by 100 to turn it into a decimal, and then multiply by the total population. So the example I just showed you before, I had the two raw numbers and then I created a percentage. Here I have the total population, the percentage, and then I can get a raw number. So in this county, there are 1,416 Hispanic people out of the 55,000 that live there. So again, here's just another example where you can take the data you have and then create another column of something you're interested in, if you're interested in that. Okay, let me show you a couple more commands here. So this next command, it asks this question. So in this data frame, I have things broken down by county. Suppose though you want the total Hispanic population in Alabama. So you don't care about county anymore. Like suppose you opened the spreadsheet because all you cared about was the number of Hispanic population in Alabama, and then the size of the Hispanic population in Wisconsin, and so on. That's what you want. So if you want that kind of information, you're gonna have to tell Python like, hey, within Alabama, take this number I just created and add it to this number, and then add it to this number, add it to this number, and so on. Right? Because the total Hispanic population is just the sum of the populations in each individual county. So you're gonna have to tell Python to do that. Now, you can imagine doing that the way we did things a month ago. If you ever want to add things up, like through a column, you could write a for loop to do that. Like that would be a classic exam 2 question. Just you have a list of things and you want to add them up, you just create a for loop. When we're within pandas though, of course, pandas just does that for you with a .sum command. So let me just show you that. Okay, so if you want to know the total population within Alabama, then within Arkansas, and whatever, you're going to have to group things by state. So here's this group by command from last time. So this will now go in and be like, oh, you want Alabama to all be a thing, right? Alabama is its own bucket. So I'm going to go within Alabama, then I'm going to add up all the Hispanic populations there. Then I'll do the same thing for Arkansas, the same thing for Alaska, and so on. And if you run this, see, it grouped by state. So every state was its own little bucket, and it added up the Hispanic populations it saw. So now you know that in Alabama, there are 193,503 Hispanic people in that state, and so on. It goes all the way down to 49. So recall it starts at 0, right? There are 50 states, but it starts counting at 0. This spreadsheet does not include things like Washington, D.C., or things like Puerto Rico, things like that. Anyway, so here's another thing you can do. You can just be like, oh, well, I only cared about state level data for now. So here's state level data. It's only 50 lines. So again, there used to be like 3,000 lines in our spreadsheet. But if you group by state, there's only 50 states. So now there are 50 lines. Okay, before I show you our last command, any questions or comments on that? Okay, so we're still not doing any what you might call real data analysis. We still haven't really like crunched any numbers or anything, but you can start to see the power of this library, this pandas library. So next week we are going to start sort of crunching data for real. I'm not quite sure what that's going to look like yet because I have to reorder some of the material. But anyway, okay. So the last thing I want to show you is DF3. What's that? DF3 is this thing. It has 5 columns and then all these rows. There's still 3,000 rows or whatever. So suppose at this point you say to yourself, oh, this data frame, it's living within JupyterLab. It's internal to like, see how it's open in a web browser. It's only internal to this. This as a spreadsheet exists nowhere. But suppose you want this to exist as a spreadsheet. Maybe you could email it to your collaborators or something, whatever. So if you want to create a spreadsheet of this information that now lives outside the program, you can do it with a command like this. You can say, well, DF3 That's the data frame I want to create as a spreadsheet, and then .to.csv, tell it where you want it to go and give it a name. So my file, and then you need this little command here for hashtag reasons. Don't worry about it. So now if I run that, and hopefully this works on you guys' computers. Most things work cross-platform, but sometimes on PCs things mess up. But notice on my desktop now, there's this thing called My File, and that wasn't there before. And there are the 5 columns. So again, this is really nice that you can like eat in the original spreadsheet, slice and dice it however you want to, create a new column if you want to, and then in the end, you can create a new product, a new CSV file that again, you could throw into your Dropbox for you and your collaborators or whatever. Okay, so those are the commands today. So much of this, did I close it? Much of these commands were not new. Some of them were, like creating the new columns. But much of this was just like this group by and summing and sort values. That was stuff we saw on Monday, but we were doing it with a tiny example where we didn't need it. But now you can see how you might need this, right? This original data frame, let me scroll back up. Original data frame is huge. So it's useful to have all these commands. Okay. Any questions or comments on the material? Okay, so we don't have that much time, so I'm not sure if it's worth going to breakout groups or not. So let me just open the problem set for today. And oh yeah, these aren't due until next week. That's why there's no link or anything. They'll be due on Wednesday. Oh, sorry, I should say one more time how you turn things in, because people asked about that last time. So suppose your homework was to do all this, right, what we just did. You have 2 options for turning this into me as homework. The first option is you can go to this little slot that you have for your file in Jupyter Lab. You can right click on it and see there's a download option, download, and it just downloads that for you. And it creates something called Untitled 65 blah, blah, blah. So you should not leave that name. You should give it a real name, like Friday, April 16th would be a nice name. And then you can just turn this in with the other one. So you don't have to combine everything into one file if you don't want to. And now notice this .ipynb, if I try opening that, it's like, what? You know, I don't know what this is. But I can open it in Jupyter Lab. So if you take this and like drag it in over here, it shows up somewhere. Right, so I can see there it is, right? I can open it in Jupyter Lab, look at it and grade it there. So there's one option for you. You can just grab these notebooks. There should be one for Monday, one for Friday. There'll be another one for Monday next week, and just turn them in individually. If you don't like that, you can just go through and copy and paste each line like this, just like my sample code documents. Like this, and I'm not going to do it all, right? But you can also turn in files like this if you want to. Again, you have to have these things clearly labeled, you know, like always, like Friday, April 16th, whatever. So there are 2 ways you can turn things in. Okay, so let me just look at the problem set for today real quick and see if anybody sees any potential stumbling blocks. Well, first of all, I guess I am ashamed to have a typo there, but whatever. So in your homework for today, there are 2 spreadsheets that you're going to start playing with. One is called LA zip code population data. One is called countypres.csv. And let me show you where those are. LA zip code population data. Whoop. No. If you click on them, they should automatically download. So I'll click on both of them. Okay, so here's countypres. Here's LA zip code population data. So for you and your problems, the first thing you'll do is you'll drag both these onto your desktop. They're already on my desktop, so I won't do that. And then the first thing you'll do is eat them in. So import pandas and then read them in like this. And then you should check to make sure it read in properly. And then after that, you just use the commands we have to start answering these questions. So let's just look at these together for a minute and see what you guys think about this. So actually, let me open open the LA population. Okay, so there's a bunch of columns. These are all zip codes that somehow intersect with Los Angeles County. So there's a lot of zip codes like that. So this zip code, here's the total population of the zip code, median age, the total number of males, females. What is this? Oh, total number of households and the average household size. That's what's in this file. So suppose I asked you like, hey, average population size of the zip code. So I'm asking for an average of these. How would you do that?
Would you use the .mean command?
So you can try. I actually don't know if that works or not, because I've only ever seen that used with .group by. So you group things by state or whatever, right? And then you use .mean. I don't know if it works on just this column, but there is a command we have that, among other things, will show you an average. It'll actually show you more than an average.
Oh, describe.
Yeah. So you can ask it to describe this column for you if you want to. That'll give you an average. It'll also tell you the smallest, things like that. So A and B are both from the .describe. Median, it tells you a median also. It gives you all sorts of little goodies, right? So that single command can knock out several of these. Average number of males, average number of females. Now you're just describing different columns. You can ask for a description of that column or that column. So there are lots of questions here, but there's not a lot of code required to answer them because of how powerful Pandas is and how much it'll tell you. So for example, if you want to know the range of something, then you need to know the largest and the smallest in whatever data set you're talking about. So I guess here we're talking about zip code populations. So if you want to know the largest and the smallest, there are several ways of doing that. So again, I'll let you think about it, but describe seems like a good thing to use. You can also sort from smallest to biggest or biggest to smallest to see the max and min, whatever. There's lots of things to do. Okay, so just looking at these questions or maybe looking at this one, it's the same kind of thing you'll do on this one. Does anybody see any potential stumbling blocks? Does anybody have any questions that they want to address? Anything worrying you about the commands we have?
So when we're giving you the answer, we just give you like the number in this case, like on a Word document?
Oh, yeah, so that's a good question. Yeah, so as always, you can give me, so I do want the answer here. You can give it to me within the JupyterLab notebook or within a text document or within this if you want to. You just have to provide it somehow. So if you want to give it in the JupyterLab document, like let's say this cell is where you answered that. You can just do a little comment like this and give me the answer. So maybe the answer is like 3,000, like that. Or you can just type that if you want to. Then when you turn in this notebook, however you want to turn it in, as a notebook or as a text document, this just comes with it. Does that answer your question, Sabrina?
Yeah, thank you.
Okay. Other questions or concerns about this?
So if in our code we have our files, not to the desktop, is that gonna make you mad?
I'm sorry, if something's not to what?
To the desktop.
Oh,
Say we copy and paste our path, and
that would make me infuriated, quite frankly, because what's wrong with how I did things? No, if you want to put them somewhere else, because again, nobody should emulate how my desktop is, right? That's a bad example. I'm setting a bad example for you and for my children who mess with my computer. Yeah, so if you have another file, you just have to give it or folder, sorry, you have to give it the right path here. But no, you can do whatever you want. Then when you turn in your notebook to me and I want to grade it, I will throw the file on the desktop and just change the file path myself when I grade it. Other questions? Okay, so we have like 15 minutes left, so I don't think that's enough time to really worry about breakout rooms. So as you try to answer these, this is not due until next Wednesday. Just as always, make sure if something goes wrong for you, if you can't access the computer lab, if Anaconda used to work for you on your personal computer, but now it's not, anything like that, make sure you just shoot me an email. And again, I apologize for those of you who've had Anaconda issues. IT is working on it. And again, they basically told me we should be fine as a class through May. So hopefully that works. But if not, I'll figure something else out as it comes up. All right. So anyway, so shoot me an email if something is bothering you. Otherwise, I'll see the Monday people in class on Monday and the Wednesday people in class on Wednesday of next week. So see you then.